Hello everyone and welcome to our presentation on power electronics. My name is Pooja Kote and I am here with my group member Amit Mari. Today we will be discussing an important topic in stability analysis, interactive board plot and Nyquist plot in MATLAB. We will explore how these plots are used to analyze the stability of system in power electronics. We hope you find this session informative and engaging. So let's get started. First, we will see the board plot. A board plot is a graph commonly used in a control system engineering to determine the stability of a control system. A board plot maps the frequency response of the system through two graphs. The board plot magnitude plot expressing the magnitude in decibel and board phase plot expressing the phase shift in degree. In board plot there is a gain margin and a phase margin. Gain margin greater will be the gain margin, greater will be the stability of the system, and phase margin greater will be the phase margin, greater will be the stability of the system. So now we will see the MATLAB code. Start with the MATLAB code first. First, define the numerator of the transfer function num equals to 10. Define the denominator of the transfer function den equals to 0.04, 0.5 and 1. Then create the transfer function using the numerator and denominator u equals to transfer function num comma den. Then plot the board of u. Then add a grid line to the board plot, grid. Then hold the current plot to overlay additional plots if needed. Hold. Add a title to the board plot. Title board plot of g of s equals to 10 upon s 1 plus 0.04 s 1 plus 0.1 s. Then calculate the gain margin, phase margin and crossover frequency margin of u. Then we will run this code. The output of this code is this graph. This is a MATLAB graph. We also calculated the theoretical graph for this transfer function. This is a theoretical graph. So both the graph are same.
So hello everyone. Now we will talk on Nyquist plot. Nyquist plot is a graphical representation of a system's frequency response, commonly used in control system and signal processing. It is a polar plot of complex function g of j omega, h of j omega, where g of s and h of s is open loop transfer function of a system. The plot is useful in analyzing the stability and performance of a system using Nyquist stability criteria. The Nyquist plot consists of a curve that traces real and imaginary parts of g of j omega and h of j omega, as frequency omega varies from 0 to infinity and minus infinity back to 0. This plot helps engineers determine whether a closed loop is stable by evaluating how the curve encircles the critical point -1, 0. Now we will have some look at key features of Nyquist plot. So it helps access stability using Nyquist criteria. Second, provides insights into gain margin and phase margin. Third, useful for analyzing systems with time delays and non-minimum phase characteristics.
Now we will see code for Nyquist plot in MATLAB. First we will define the transfer function's numerator. Num g equal to square bracket 1. Now we'll define the denominator of transfer function. Then g equal to square bracket open 2310 square bracket close. Define the transfer function g equal to transfer function numerator comma denominator and use display the function display g of s figure Nyquist round bracket g then grid function grid on then title Nyquist plot of g of s equal to 1/1 s of 1 plus s into 1 plus 2s then we will calculate the gain margin, phase margin and crossover frequencies. We will denote it by GM, PM. GM as gain margin, PM as phase margin, WCG, WCP as the crossover frequencies. Now the output we get from this code and the output which we get by theoretical calculations is almost the same graph. So both the calculations of theoretical and the simulation both are same. So we came to understand that both the calculations are almost correct. Thank you.